For decades, building a network meant sitting in a cold room and typing text into a single router at a time. The command line interface, or CLI, was the only way to tell the hardware what to do. If you need to update one device, typing is fine. But if you have to push a critical security patch to 500 switches, that manual input becomes an all-night marathon. When fatigue sets in at 3 in the morning, typos happen. A single missed character on switch number 412 causes it to fall out of sync with the rest of the system, opening a silent security gap that might go unnoticed for months. As long as the brain of the network lives inside the individual box, an engineer will always be forced to address those boxes one by one. To break the bottleneck of human typing speed, the decision-making logic has to be pulled out of the hardware and moved to a central location, where a single instruction can reach every device at once. That separation relies on software-defined networking, or SDN. Think of it as a central command center for your entire infrastructure. Instead of 500 routers making their own isolated routing decisions, they surrender their logic. They become silent messengers, taking orders from one massive centralized brain, the controller. But this creates an immediate architectural problem. If we removed the human and the keyboard, how does this central brain actually deliver its instructions down to the hardware? A central intelligence is useless if it cannot speak to its subordinates. The system requires a standardized high-speed transit network dedicated entirely to carrying automated instructions. We solve this with REST APIs. You can picture an API as a fleet of high-speed digital couriers, waiting at the controller to instantly deliver commands to any device on the network. These couriers travel over HTTP. They use the exact same underlying protocol that your web browser relies on right now to load a web page, entirely repurposed to manage physical infrastructure. These couriers only accept 4 specific instructions. GET reads a device's status and takes a snapshot. POST drops off brand new configurations. To make a minor adjustment, PUT updates the existing rule. And if a policy is obsolete, DELETE wipes it entirely from the hardware. But GET, POST, PUT, and DELETE are just actions. They are the verbs of our network. A courier still needs an actual package to deliver, a standardized payload that the router can easily read. That package is formatted in JSON. It's a lightweight, universal data language used to wrap up the controller's complex instructions into a clean, organized payload. JSON structure is incredibly simple. It starts with the object, always enclosed in curly braces. Think of an object as a digital file folder. It cleanly groups related characteristics, like the host name and physical location, for a single device. Inside that folder, to list multiple items, we use the array, enclosed in square brackets. Arrays function exactly like bulleted lists. They perfectly stack sequential variables, like assigning 5 different VLAN tags to a specific port. Because JSON relies on this strict, highly predictable grammar, machines can read it instantly. There is no ambiguity, meaning a complex intent written by a human is executed exactly as designed. Let's put the entire stack together. Today, an engineer doesn't touch a mechanical keyboard to configure a router. They sit at their desk and write out their network intent purely in JSON format. They hit send, and the SDN controller takes over. It processes that JSON payload and instantly fires off thousands of REST API requests, sending our digital couriers racing across the network to every connected device. What used to take 3 days of exhausting, error-prone typing is now executed flawlessly across 500 routers in a single millisecond. Infrastructure is no longer a collection of physical objects to be touched. It is a digital service managed through a screen. The physical act of walking from rack to rack with a console cable has been replaced by the logical act of managing an architecture. Because the tools used to build a global network are now the same tools used to build a web application, the boundary between these disciplines has vanished. To command the network today, you must command the code.